So 4.4 is building quadratic models. So let's look at question 1. An individual's income varies with age. The table shows that the median income, I, of individuals of different age groups within the United States for a certain year. For each age group, let the class midpoint represent the independent variable, X, and for the class 65 years and older, assume that the class midpoint is 69.5. So we're going to complete parts A through E. So one thing, if you think about a person's median income, that's kind of like an average income. You notice as you're young, you don't make much money. And then as you get older, you start to make a little bit more money. But then once you get closer to retirement age, you kind of start to be a little more conservative and your money will start to kind of lose value a little bit. And so it kind of bounces out. So there's going to be this maximum value. Nowadays, it varies because, for us, a lot of us are working longer. We're working past retirement age because we just enjoy working. So let's see what we got here. Part A is going to be related to this table over here. So, what they're saying is if you're 15 to 24, they're just going to use 19.5 as a midpoint there. So if you're around 19.5, your median income is around 11,000, if you will. So as you get to be age 29.5, your income is 33,000 or so. 39.5, 42,000. 49.5, 46,000. 59.5 is 42,000, and 69.25 is 23,500. Now remember, income varies from state to state because cost of living varies from state to state and even from city to city for that matter. So this has a lot going on here when it comes to looking at people's incomes because it's also based on where you live as well. So it says use a graphing utility to draw a scatter diagram. So if we remember, that's under stat plot here. So we're going to have to use stat. It's going to be one of our main keys, and the stat plot is another key that we're going to be dealing with. So notice that stat plot is in blue. So I have the second button, stat plot. Notice that my plot 1 was turned off because we were doing some other math. So I need to turn that back on. So if I hit enter again, it'll turn it back on, and it's already set for scatter plot. And notice that the X list is L1, Y list is L2. That all looks good. So we're done with this. So we can now quit. So now if we want to put this data in, we're going to use the stat button, and we're going to use the edit button from there. And remember, to clear out data, we kind of go up to highlight L2, hit clear, and then drop back down. Scroll to the left, go up to L1, hit clear, and scroll back down, and we can enter this data. So I'm going to pause the video for a second, and I'm going to enter this data into the calculator. So I did have my list entered into the calculator, and this is the hardest part. You may want to, before you move on, just maybe double check the data since there's not a whole lot here to kind of look at. And I don't think I've got anything that looks suspicious here. It all looks okay. So the next thing is we're going to try to identify which of these graphs should it mirror. And again, notice how it should start out low, and notice around the middle, it kind of peaks out and goes back down. So my instincts right now are kind of leaning me towards, it's kind of leaning me towards this graph here. Notice that it does tell me something about the viewing windows as well. So it does tell me to go in here to the window, change my window from go like 0 to 80 and go by tens on the X scale. And the Y scale, they're saying go 0, looks like 60,000. And then go by 10,000s. and then you could graph it. Now, what you can also do, remember, if you just hit zoom and number 9, it'll do the scale for us as well. So notice it's not quite the same, but it's close. So either way, if you don't want to change that window, you can use zoom stat to it'll create a window for you. So under zoom, if you choose number 9, zoom stat, you won't have to mess with the settings of the viewing window. It'll be close enough. But you can go in here and it'll be just like really perfect. Notice how it still matches the graph that our instincts were already telling us is that one, because our income was increasing, then it was maximizing out, and it started decreasing. So the next question is, which type of relationship do we have between the two variables? Notice that it's kind of quadratic. Now, does it open up or open down? And since it opens down, we know A has to be negative. A has to be less than 0. So it's quadratic, and A would have to be less than 0 since it's opening down. So that means it's going to have a maximum value. Part B says, use a graphing utility to find the quadratic function of best fit that models the relationship between between age and median income. So this is where, again, we're going to go back to stat. So we'll hit the stat button, and we'll slide over to calculate. So slide over one. And notice the one that does quad regression, number 5. So number 5 is that quad regression. That's going to give us the quadratic function best fit. So if I choose number 5, notice that we are using L1 and L2, so we'd have to change it there. So if we calculate, notice it gives us our coefficients of our A, B's, and C's. So we have the coefficient of x squared is going to be this, and we do want to round to 3 decimal places. So that's going to be negative 46 point. Is it going to be 538 or 539? Since there's a 3 after the 8, it's going to stay at 8. 538. Notice that coefficient is a negative, so that means it does open down, like we were saying. A is less than 0. And then the next thing is we want the coefficient of x, and notice how it's got a plus sign here, so it should be positive, and it is. So we have this 4, 4, 1, 2 point, and it's again, it says 3 decimal places, so it's going to be 714 or 715. Since there's a 1 after the 4, it rounds back down to the 4. So 714 goes there. Notice it's already got a minus sign, so we don't have to put the negative there. We just have to put the 57,400 point, then 594. So that's going to be our quadratic function of best fit. So use this function found in part B to determine which an individual can expect to earn the most income. So at what age can we earn the most income? So to me, this is going to be, well, we're talking about the maximum value. So let's use the calculator and put this function into the calculator. Y equals, so I'm going to have this negative 46.538 x squared, if you will, plus then 4,412, and then 714 on the decimal, and then minus then this 57,400, and then 0.594. So if I graph that, where's my graph? It should be there. Y equals plot 1. I don't know what happened there on that. I forgot my X there, didn't I? So see if we can insert that without having to do it all over. So there INS, second insert. Let's see if I can get an X there. Now let's see if we graph it. All right. Okay. So now I did get it to Panther. I just forgot to put that X in there. So if we go to the calculate button, it'll find me the maximum value there. So if it's second calculate, number 4 is a maximum value. So if I have to be just left of a little bit, that looks good. I gotta be kind of right of it a little bit. So it looks like I'm on the downslope again. Hit enter. Notice it does take me to the high point. So it says round the answer to the nearest tenth. So we're saying 47.4. So at 47.4 years of age, I can expect to earn the most income. So use the function in part B to predict the peak income earned. So the peak income is going to be the Y value here. So the peak income for this individual would be like $47,202, and we went around to the nearest dollar. So would that be 202 or $203? So since there's a 3 in the tenths place, we just keep it as a 2 then. So we do just want to round to the nearest dollar. Don't need a decimal point then. So we went on and used the graphing utility there to kind of save ourselves some trouble. And so this shows both pieces for us there. So the graphing utility graph the quadratic function of best fit and this on the scattergram. So, and that would represent what we're talking about there. That looks pretty good. Okay.